Okay, so could we start? Hello everyone. First of all, a disclaimer, I will be speaking in English. I'm quite sure it was written in the description of the event. And I'm actually super proud of all of us that on Saturday morning we're all here coding and doing the stuff we love. I'll be speaking shortly about TDD, but first of all I'll introduce myself for those who don't know me, and for those who know me, well, maybe you will find some new facts about me that you didn't know. I'm Mindaugas Ječionis. I'm a senior front-end engineer here at Tesonet. I'm actually working in this building, so I'm currently feeling like at home. I'm also lead lecturer at Code Academy, co-organizer of YGLF Lithuania, which translates into You Gotta Love Front-End, which is first front-end conference here in Vilnius. We had an amazing conference this year, and we are having a next one next year. So check that out. I'm also a tech enthusiast. I'm aspiring speaker, hence I'm here and speaking. I'm semi-geek, not full-on geek, because in my book it's a full-time job and my schedule is pretty packed, as you can see. I'm in constant student mentality, and the most important thing for our presentation today is I'm the one who sleeps at night calmly. Why, you might ask? Well, because during the day I TDD, or also famously known as intro into TDD. Before we head on and find out what is TDD, I want to ask who knows the meaning of this abbreviation? Can you raise a hand?
Okay.
Okay, so for those who know, they know. For those who don't, TDD stands for test-driven development. And yeah, this perfectly illustrates that TDD is not for everyone. When you're building bridges, you probably don't want to test them with real cars. But before I step into TDD and what TDD gives us and why we should use it or how use it, I want to step a little bit aside and talk about what is TFD. Again, I want to ask to raise the hands who knows what is TFD. Close enough, yeah.
Test
focus.
Something like that.
Yeah,
Yeah,
exactly. Test first development. And I always thought that TDD is TDD, but there's more to that. So how TFD goes? TFD goes like this. You write a test and you check that test fails because you write your test first before you write any code, so there is no functional code to pass the test. Or if there is a code and you're adding some new functionality, it should be still failing usually. And then you write code according to requirements, to business requirements, so the test passes. And then you skip back to the first step and repeat. So for me it sounds really like TDD, but TDD actually is the same, just extra. And that extra is refactoring. After you finish your third step and your code passes the tests and you're happy about that, you should look into your code and examine if there is some duplication, if the code is clean enough, if it's performant, and you should do some improvements. And while you do those improvements, you might break the tests and your tests might start failing again. So you either roll back or do some additional changes, and eventually you have a code that is not only passing the tests and passing the requirements of the business, but also is clean and good to use. Everyone loves graphs, right? I assume, and I don't ask this question, I know. So this is how TDD works actually. You have your requirement, you have your test case that is initially failing, then you code and your test succeeds, and then you make your code good, clean code that is performant, and then you test again, and your test either fails or succeeds. If it fails, you either roll back your refactoring and refactor differently, or you don't refactor, or you move on and add additional code on top and do different changes. When it succeeds after refactoring, you jump back to the requirement, because usually business requires us to do more complex things and have more than one requirement for our feature, and hence we have a next requirement, next test, and we move on like that. So I write tests, so what? Or also famously known as convince your manager. I've seen a lot of times situation like this. Developer, yay, let's do tests. And manager is like, no, that's a waste of time. And I prove you wrong, or your manager wrong. First of all, I sleep better at night if I test. And well-rested developer is a performant developer. Everyone loves performance. Tests ensure that all business requirements are fulfilled. I haven't met a single product manager or project manager that would say, we passed just 3 requirements out of 5, it's okay, let's move on to the next feature. No, we have to follow all the 5. And tests, they ensure that we cover all of those requirements in tests, hence we cover them in code, in functional code. It forces you to think. Like development requires you to think creatively and everything, but it forces you to think beyond the requirements and forces you to think about different cases, different use scenarios. If your inputs might be different, if you have some edge cases, and hence this allows you to cover your code better and make more well-designed code and more maintainable and scalable code because it's more well thought out. Again, I want to ask to raise the hands who has been in a situation where you're like, write everything and you do your magic with the code and then suddenly, forgot this one, and then you have to squeeze in another function or another requirement into the module or something and it doesn't fit there, you have to refactor half of the thing. I at least have been there. Okay, so it also impacts, as we can understand from the previous point, it impacts your quality, your code quality. TDD goal actually is clean code that works, and every manager loves code that works because if there's bugs, you have to return, you have to reiterate, and business might as well move on with the next feature instead of fixing some stuff that is not working. So TDD actually saves time. This is the first argument that you will hear from someone who thinks that you shouldn't do TDD. It's like, it will take longer time. Let's write code now, let's implement everything, and we will come back in a week, in 2 weeks, and we will cover with tests. Well, that's not how it works. There's always something to do, and rarely this scenario goes on like that. And from my experience, if you spend an hour on your code and the feature is done, you spend an hour and a half or 2 hours with your code and your tests because there's more to do and more thinking involved in that, and more edge cases to cover and everything. So it's like 1 hour versus 2 hours. But in the long run, it's actually 2 hours versus many hours, because if you don't cover with tests, someone will come back months later to that code, write some additional functions, write additional stuff, and break something unintentionally. And then you have a manager running into your office screaming like, we're down, this is not working, let's fix it. And yeah, this in the long run saves time for you. So I have a bold statement before we move on, and that bold statement goes like this. Refactoring without tests is like moving chocolate yogurt emoji from one place to another. It's a code, it might be working, but might as well not be working. You don't know, you have no idea. Did you just break some stuff that was there, or did you improve? Well, who knows? There's no tests to prove that. So TDD is actually for the confidence, for our confidence, for team's confidence, for everyone's confidence. And how many times you had this situation where you don't want to touch that part of the code, that part of the software, because it's a mess there. I've been there. I've once inherited the outdated code base that had 0 tests, and I had 0 knowledge about this software because that was a browser extension for productivity and security, and well, it was working with browser APIs that I had no knowledge of, first of all, and second of all, I had no knowledge of building building browser extensions. So I was super scared when I got this project on my hands and some requirements to like implement something. Today I'm not so scared about this project because it's well rewritten, covered in tests, and anyone can jump in and do whatever we need. So TDD gives you confidence in refactoring. You refactor if your tests fail, you refactor wrongly, and then you have either your business requirements change and you have to update your tests, or you have to update your code, which is more common case. Writing tests before functional code means you gave it a thought. I cannot stress this. I'm repeating this point like third time now, but I cannot stress this well enough. This translates to better coverage of your code. If you write your code and then you write afterwards tests, do you really cover all the cases that you would have thought about before? Well, you might cover the exact same amount that you would cover writing your codes before your tests before your code. But in my practice, and usually this is a tendency that you find some loopholes in the business logic of that. You find something that has to be either rearranged, or you think of the scenarios that end up in extra tests, which end up in extra confidence because you cover extra ground here. And this means good night's sleep if you're confident with your code and tests. And agility. I mean, confidence, agility, how speed is related to confidence. Well, actually it allows developers that have zero knowledge of code base jump into the code base and do some additional stuff. Coming back to my example with browser extension, now when it's fully refactored and covered in tests, and we recently got a new software engineer on our team and got some requirements to do something, that person just asked me how to set up that project, and that's it. And he was able to do all the business requirements because there was tests to support him, to help him and guide him. And when you're confident that you can deliver on timely basis, then again, this translates into good results and good code quality and overall confidence in your team from your management. So this is me when I jump into the code base that has tests. I'm super confident and I'm ready to do my jam. So, how many of you are lazy to write documentation? I am. I definitely am. There's quite a few times when my colleagues during code reviews say, nice code, Minda, good job, but could you add something into our README or our documentation, because nobody will remember that half a year later, or won't understand this because this is a confusing piece of code, or this is a library that a third party is using. Okay, then I jump back and I write a README. But everyone loves specification. Like you read the specification and you know what this is, and your tests can be your specification. Just from the glance at tests, you can understand what this code is meant to do. What is the purpose of this code? What is the business requirements? You can know all the requirements just by checking the scenarios, also not only the business requirements, but the extra requirements that you found out during thinking about how you will write your code, how it will work, and what results it will give you. And yeah, just by checking that, you know all the requirements. And future you, or future me, will know what to do with that code. You will come back and you will know what actually this piece of code does, this piece of software does, which translates into, again, more confidence and, again, a better night's sleep or calmer days and nights. Future you is a really nice thing to talk about, because there was a really nice article I once read which said the code that you wrote today might as well be written by someone else in 6 months. So when you come back to the code base 6 months later, do you really remember every nitty-gritty thing about that code? Do you really fully understand it? Like from the glance, you just look at the function name and you're, oh yeah, I know every line by line, everything. Probably not. At least if you're like me, you don't remember that a week later. So future you will thank you for the tests that are your documentation. So now that we covered all the motivational stuff and how to prove to your manager what codes you should, what tests you should write. And disclaimer, this is a personal opinion. There's a debate going on about these things, how many tests, what tests, and so on you should write. This is totally personal. You might not agree with me, but that's up to you, and this is up to me. I'll share my opinions. We can discuss afterwards with a cup of tea. Maybe you'll prove me wrong. And another disclaimer, I'm quite sure that not everyone is working with JavaScript code base here, so I'm truly sorry for you guys, because the tools that I will introduce now are the ones that I use on daily basis here at work, and this is what I use to cover our projects, and as a front-end engineer I work with JavaScript. So, first of all, do you know this triangle that shows you the products that you can eat the most, then less, and so on? This is like healthy diet pyramid. So for the tests you have the same. You have your unit tests. I think this is the biggest part of your tests. This is the most that you should have in quantity. Afterwards you should have UI tests and component tests, and then integration tests and API. A smaller portion goes to end-to-end tests. That's what E2E stands for, end-to-end tests. And the top one is actually not Illuminati. It's not tests that are watching over you, over your shoulder. You have manager for that. That's actually your manual tests, your manual QA, quality assurance. This is someone that will cover the cases that you cannot cover in code. For example, I have no idea and I haven't found a solution to write tests that cover end-to-end journey for the user that has a browser full of browser extensions. I can test the user's journey on specific browser and stuff like that to write automated tests for that, but automated tests that decide the different browser extensions, different operating systems, different versions of browser and stuff like that, well, that's hard to cover, and that's why we have these people that cover that for us. So, unit tests. Why so much? Why the biggest portion? Because they're easy. They're like super easy to write. You write a few lines of code and you have your test, then you write your functional code and so on, and you iterate, and it's super easy. They're like really easy to write. They're also quick in two ways. They're quick to run. Unit tests, they test only one unit, single unit of your code, and by single unit I mean like one utility, one module, one function. Well, module might be too big, depends on the module. And they're quick to run. You launch your unit tests and they run really fast. And another quickness here is because they're so easy to write, they're quick to write. You write them really quickly, you don't really waste that much of a time. And they cover your units in single manner. You have your single unit and tests for them. And this is great because you know that your unit works in isolation, which means that you can take that unit and put in another project that has the same inputs and stuff like that, and you can expect to give the same outputs, or you can extract that and put it in a shared module and install throughout your projects, different projects, if something that is hard to implement but maybe very much reusable. Also, UI tests. Those are really a much thing. Some people, when you say we're testing our UI, they think about manual tests, but no, actually you can test your UI. You can either do visual regression, which is checking your project's previous version, previous screenshot of your project versus current project, and check if there is some visual regressions, like the button disappeared, or the spacing between the sections in your landing page is a bit bigger or a bit smaller, and this is maybe inconsistency and stuff like that. Also, you have tools that allow you to imitate the actual DOM that you're outputting to your user, and DOM is document object module with model which represents your actual website, your UI, and you can imitate the rendering of that and check what you have, what you will output to the user, and what will happen. Integration tests are the ones that handle the thing and make us feel confident about the parts that connect to each other. We don't want to have situations where pipes just don't connect. You have your units, they work on them own perfectly, but once you connect them, you get unexpected results, or if we come back to analogy of pipes, pipes are leaking, not connecting, and you have maybe to write some glue code there, and the tests will show that for you. Integration tests just test the whole pipeline, because usually it's not single function that you run, it's a lot of smaller modules and units that cover one requirement or multiple requirements. Then you have your end-to-end tests, and they basically ensure that you your user has a safe journey from point A to point B, maybe via point C. Imagine a website and you want to check if the new user can log in after successful registration. So point A is I jump on the website, point B where I want to get is a successful login, point C is the middle part, which is illogical because alphabet doesn't go like that, but it's logical for our analogy. It's the part where a user registers and only then logins, does the login. So, and manual tests, well, who has heard this term smoke test or sanity test? Cool. So yeah, those tests basically check if the product that you're shipping, let's say you're shipping a car, is not smoking when you turn on engine. It's like, or I don't know, the wheels won't come off while you drive 2 circles or something like that. It's called sanity tests because it would be insane to not actually check your app or your software, like how it is working on actual device and stuff like that, before shipping to production, shipping to your users. That's why it's called sanity tests, and that's why it's called smoke tests, because you check if smoke isn't coming out of your software. So, tools. I just covered everything, but there was no tooling. And as I said, as the disclaimer said, this is more towards JavaScript. For unit tests, we use Jest because it's close to zero configuration. Actually, you can just install Jest and start writing your tests immediately. There is some configuration if you want to squeeze some extra out of it, but it depends on your use case. For integration, actually, we use the same thing. It is still Jest. Just if you decide to write integration tests and unit tests with the same technology, you might as well have some separation between integration tests and unit tests. Usually what I do in my personal projects is I name my tests with this middle part which says unit or test maybe, and then I have an integration middle part between my file name and file extension that would state that this is integration test. You can go further into just configuration and configure it to show on terminal while tests are running that this is now running integration test or unit test by labeling those. For UI, since our code base is in React, we recently switched in few of the code bases to React testing library, which allows us to simulate actual DOM that we output to our user and check what we have there and what the button clicks do and stuff like that. If you work with some other technology, I don't know, Angular, Vue, Svelte or something like that, or you're going to pure vanilla JavaScript, then you have your alternatives there. Under the hood of React testing library, there is a DOM testing library which basically allows you just do vanilla stuff. And from there, there's a lot of multitude tools that you can use. End-to-end tests, we use Cypress because Cypress is not only a tool but a platform, and platform gives us really nice things like video replays of our tests. Like if you get a notification that some of your end-to-end tests failed, you can just jump into a Cypress platform and replay those tests and see actually what was happening. And you suddenly realize that you have a test that is checking if user on a banner is trying to click a second button, but there is no second button anymore because you decided to go on with just single actionable item in a banner. And yeah, that means that, well, business requirements changed, so you have to update your tests. Most often, as I mentioned, it's the other way around, it's vice versa. and you can just replay that, which is cool. And for manual tests, well, there's again multitude tools, but the one tool that our QA guys wouldn't live with, guys and girls wouldn't live with, is browser stack. Sadly, this is a paid one, but it gives you like 100 minutes of testing for free after registering or something like that. And yeah, I would definitely go with that. This would be the first paid tool that I would get in my side project that I'm wishing to roll into the production, because it allows you to install a browser extension which allows you to jump into different platforms, different operating systems, test on different browsers, and it's all from your browser window. Either you're comfortable with Firefox or Chrome or whatever, you don't have to have all the browsers, you can test that via this. And the best part is this is actually actual devices that you're testing on. This is not some virtual machines. And it's super fast. Like if you look at the browser stack tool and then you try to set up a virtual machine on your device, my Linux virtual machine on my device is super slow compared to testing browser on Linux via browser stack. And this is insane because there's also internet latency involved in here. And I just have one honorable mention that I use quite often in my personal projects, which is Puppeteer. Puppeteer is like Cypress, it's end-to-end testing library or tool, more like. And sadly, it supports only Chrome, but gladly there's experimental Firefox support there. So you can support both tests for Chrome and Firefox. Just you have to keep in mind that API might break from version to version in Firefox version of Puppeteer, and there might be some inconsistencies how you write your tests for one and for the another, or there might be some things that's not working on the Firefox side yet. So what about the code? How does it look? So with Just, unit tests look like that. And this very well illustrates my point on documentation. Like we have a function that says round. Maybe it draws a round circle on the screen. Maybe, I don't know, it makes buttons turn around 360 when user hovers, maybe something else. But if we look at the tests, I can see that I expect to give output a nan, which is not a number, when I have invalid inputs, which already suggests me that the output will be a number. Then I have a situation where I pass in 5 and I get 5 back. So, okay, I pass in numbers in and I get numbers back. Then I have a situation where I pass in 5.101 and this returns 5.1, and then another one which is 5 point multiple numbers, and this again lets me know that it returns 5.05. And out of that I can understand that round actually is not for drawing a circle or something like that, it's for rounding numbers. And it, if it gets an integer, it returns me an integer. It doesn't return me 5.00, right? If it has, if second number after the point is 0, it returns again. And I understand all the requirements just from looking at that. I haven't seen the code. Well, I have seen it. This is from my personal project, but you haven't seen, and you can understand what's happening there. And another example is like a function that's converting stuff. And just by a glance, again, I understand that it will return a number for me because with invalid inputs it returns me a 0. And then with valid input, which is 2 and 2.5, the input actually is an object which defines an amount and a rate. And I can see that with amount 2 and rate 2.5, I get 5. Which means that 2 was translated via rate 2.5. Maybe it's a currency exchange app or something like that, and this is a unit that is converting from one currency to another. And then I can also see that I have a possibility to give in numbers as strings, and it should output actual proper number for me, which might be the proper use case in user interface development, because all the inputs where you put the text, even if it's marked as number, it's still outputting text value for you, even though it's numbers in text, but it's text. So yeah, this one understands. Integration tests, we won't go too deeply into this, but this is actually a test that I wrote like 2.5 years ago while interviewing here at Tesonet and doing the homework assignment for Tesonet. This is basically checking, I have this API middleware which is responsible to doing my API calls to the backend and getting the data for me, and it's covering all the 3 parts of the request. It's doing the actual request, the success, and the failure. And it's integrating with Redux, which I used for data storage, for the global data storage. And I just see that if I dispatch an action, which is actual user login, and I pass on username incorrect and password empty, which from the test suggests that this test is for the bad inputs, bad username or something. And I can see that first I dispatched the actual fetch action, then I dispatched token failure action, which was done by the API middleware, which is responsible for that, and then eventually I got a payload which says message unauthorized, and I could even add in the status code here with 401. So just by that, I'm checking the whole integration between my API middleware, which is already multiple functions and multiple things, plus Redux and stuff like that. UI tests. For UI tests, again, as I said, disclaimer, I haven't seen the component that this is testing. This is actually from the docs. But just by reading that, I can understand that this is some hidden message component which takes in some children parameters, so some text in this case. And I can see that initially when it's rendered to the screen, I expect that I don't see the text that I passed into this component. So, okay, it suggests that the initial state of this component is not showing the text that I passed in for it. Then I have an event that clicks on a button that has a text show. This is regex that's testing for text show and doesn't check for like capitalization of letters. So all the variations will fit for me. And then I check again that now I can see the text because I clicked the button. So from that I can understand that this component actually is supposed to have a hidden message as the name suggests, and initially it doesn't show, but we have some toggle or some checkbox that allows us to show it once it's clicked. For end-to-end, we have this scenario, and quickly running through that, it's supposed to register the user, and the user visits register route of our website. It then gets the input, which is username, types the new username, then the same for the email, for the password and confirmation password. Submits the form by getting it, and then checks if our page now contains text which says registered successfully. The next test actually checks if that new user can log in. So visits login page, then selects the input for the email, inputs the email, selects the password, inputs the password, submits the form, checks that we have a message success, and eventually checks that the route actually of the website changed. The URL we were on was login. Now it's just basic domain, which is probably a homepage that shows different content based on if you're logged in or logged out. Puppeteer. Puppeteer actually I love because if we look at Cypress, there's a lot of chaining, and you can even chain like a lot of steps here. And for me, it's a bit hard to read sometimes. That's why I love Puppeteer, in my honest opinion. And it's just basically I have this test that is tic-tac-toe game, and I expect X to win. I visit the website. I register two users, where I just simply say that the page, I type something into the field which has this identifier, and one player, another player. I click new game button, and then I click one cell, which is a function that actually checks for all the cells, and by index clicks the specific one. in our grid for tic-tac-toe, and then I check after a few turns that there is no winner yet, and then again few turns, and I check that the winner is the expected one. So this is end-to-end journey, like end-to-end game for the user that won. And in this case, Ross Geller won versus Dinosaur. Hooray for Ross. So, in my experience, doing tests is great, but if there is a lot of friction and if you don't do tests before and now you start doing and you have to write your tests which you cannot go around, you have to actually write them, and then you have to constantly run them. This might be sometimes a bit discouraging. So what about the flow? What about integrating this into your flow? If I would have to start a new project, I immediately would jump into pre-commit and pre-push Git hooks that you can hook some actions to happen when you try to commit your code or to push your code. And there's a great tool for that, which is called Husky, which allows you to do that really easily from your package.json file just by writing a few lines of code. Also, I would consider a CI or CD pipeline which would check again those tests. Why? Because, well, maybe I'm working in a big team and maybe I don't trust myself or someone else, or maybe not even I don't trust, maybe I simply was in a hurry and I wanted to push the code into the branch and go off with my day because it's Friday evening and we won't deploy this anyways until Monday. So I just used no verify flag, which bypasses the pre-commit and pre-push. So my tests won't run on that. And CI/CD might just rerun those tests for me. So GitLab has built-in CI/CD. So if you're a user of GitLab, you just have to write one YAML file for that and just define the actions. They have a great documentation on that. GitHub actually has similar thing now, which is called Actions. They rolled out this year, like mid-year in summer, I think, or something, or maybe even earlier. They had a beta, but now it's live for everyone. And basically, you can write different actions for your projects on different scenarios. Like when you push to master, maybe you build your project and you ship it, which is continuous deployment. Or maybe when you push to some branch, you run your tests and other quality tooling. And there's other platforms, of course, for your versioning and for Git, and I'm quite sure they have tooling for that. I know that there's Bitbucket I believe by Atlassian, and I'm quite sure they have also the tool, if I remember correctly. And there's a bunch of third-party integrations, so if your tool that you're using for versioning doesn't support CI/CD things, you can just use third-party, integrate that into your flow, and everything happens automatically for you. So, conclusion. Tests are actually your friends. They ensure requirements are met, and the code is clean and is thought out and well designed. They give you confidence in your solutions, both for you, your team, and the manager. They save time, energy for you, the team, and the future you. They allow you to sleep calmly. And don't forget that integrating your tests into your flow will make them more seamless and more effortless. Thank you. And any questions for tests? Yeah. I'm quite sure you will have an opportunity actually to try out right now the knowledge that you got here, because CodeWars, the platform, allows you to write your own tests for your own katas, the ones that you're trying to solve, right? So there's, I believe, on the right side of the screen at the bottom window for writing your tests. You can apply that. And I believe for JavaScript katas, it's actually Jest there as well running. I might be mistaken, but the syntax is really close to that. So, please, any questions? Cool, I covered everything. Thank you.